Hello and welcome to the fourth video in this DAX series. Hopefully it will help you learn DAX faster than I did, which took me years. And this series is focused on this list of key concepts that Marco Russo described as the key 4 topics one needs to understand to be able to master DAX. And so if you haven't already watched the first 3 videos, please go back and do that, where we sort of explained the scenario we're working through. We understood the data model. We showed what was possible without writing any DAX at all. We talked about row context. We talked about filter context. That was a long video because that's a big one, and you use it all the time when you start to write more advanced DAX expressions. If you do want to follow along or get this file for yourself, you can click on the link below the video, either the clean version or the finished version with all the expressions in it. And I do have lots of future content plans, so please go ahead and subscribe to this channel as well. All right, so let's talk about context transition, and just a couple key points as usual with these. The most important thing to know about context transition is that it turns a row context into a filter context, and we'll demonstrate what we mean by that. And it requires a calculate function to activate it. It turns out, and we'll see in the examples, that when you just write a measure, you reference a measure in its form, for example like this, with just the measure name in square brackets, it is automatically wrapped with a calculate around it, so it does trigger context transition. However, if you just write an expression like this, it does not have a calculate, so you need to put that around it to be able to activate context transition. And again, we'll demonstrate this in a minute. And context transition, again, like with the other topics we've covered, applies to both physical tables, and in our case, we have the date table, the sales table, and the product table, but also it can be activated on virtual tables as well, which most of these examples will demonstrate. Okay. So the easiest way to demonstrate context transition is back with a calculated column again. And you noticed in the series so far, we haven't done much before one of the first videos about calculated columns, because if you can do something in a measure, I always recommend to people that you do, and you reserve calculated columns for when you need to use values in a row or column header, or along the axis, or in a legend of your visual. But for most of the analyses you do when you're putting stuff in the values area of your visuals, you should almost always write those as measures. So let's go and we'll go over to the product table. And so we'll click on product table. And so what we're going to do is we're going to add a calculated column where we're going to go over to the sales table and just sum up the sales that are in the sales table for the product table. Again, you typically wouldn't do this. We'd do it as a measure, but this is an important thing to see and understand for situations where you may do something like this in your model. So we're going to go ahead and add a new column. And remember, we talked about calculated columns last time when we talked about row context, that when I type an expression here, it knows what row that I'm on. I don't need to tell it, right? So it knows this is the product A column, or the P1 product ID. So let's just call this sum of sales. And we're going to say, give me the sum from the sales table, and I want the total sales. Remember, we had calculated that as a calculated column. So we're going to go ahead and sum up that value. And what you might expect is, okay, we have a relationship from the product table along the product ID column over to the sales table product ID. And so one might expect that when we hit enter on this, that we would go over and that would sum just the rows that apply for this product. And that's not how Power BI works, how DAX works for this. Now, in a visual, if I had made a visual that said product ID and I put the sales measure in there, it actually would apply that as a filter going through that relationship and give us the expected value. However, when we do this in a calculated column, that does not occur. And so the reason that is, and if you look, we see we get all the same values here, and this is actually the sum of the whole sales table. And you may remember this 120,000 number from our previous video. And so what we need to do is to trigger context transition. So I mentioned context transition changes a row context into a filter context. And that's kind of what we want here, right? We want to be able to say, hey, I'm on this row, the row for product A or product ID P1, and I want to use that as a filter context when I go over and get the sum of that column. So I mentioned before that we could wrap this in a calculate, and it would therefore trigger context transition. So let's try that. And when we put that in, we now get the correct answers, where it goes over and first filters the sales table for product ID P1 and then calculates the sum of sales. Okay. Now, when I covered those notes, I also mentioned that you could just write the measure form of this. So if I just put the total sales measure, which remember is our sum of X measure that goes and iterates across there, and put that in there, you'll see that we get the same numbers back, and I don't need to wrap this in a calculate. So this referencing a measure like this automatically has an implicit calculate around it. Okay, so that's a key concept to know, because we'll be creating virtual tables in a second, and we'll put measures in there, and so it's important to realize that those are wrapped in a calculate, and those are actually triggering context transition, where it takes the value for the current row that it's on and uses that as a filter for whatever calculation we call. Okay. All right. So that demonstrate this. All right. So now one of the things our consumers requested was, I want the maximum the sales for whichever product had the maximum sales. I want to see that value for we assume for a given month. So let's make a simple table visual, and we'll add that year month column again. Actually, let's make this a matrix just so that we can demonstrate what we're talking about here. Okay, and we'll put total sales there, a total sales measure in the values area, and we'll put product across the top. Okay, and so this is what we're talking about, that for any given month, we want to know whichever one got the max, we want to know what that value was, right? So in this case, it would be 616. In this case, it would be 660. Like it's always this one, and that's because we have more products there. So again, we want to get that maximum value, whatever it is. So let's just go ahead, and we'll keep this open just for reference there. We'll make another table over here, and say we don't want to waste all that real estate on to show all the products and make the consumer have to scroll across like we just did to figure out which one was the max. We'll just make a table visual here. We'll add our year month column, and let's make a new measure. And we'll just call this max single product sales or something like that. Okay, and so what we're going to do is we're going to do another iterator function. And again, you will use these all the time. They're very valuable. And this pattern I'm about to show you is a really useful pattern for this type of thing. So what we want is we want to create first a virtual table of all of the products. Okay, so what we're going to do is we'll just use all here. We could also use values. So let's use values. So basically this will give us the list of products that had sales in whatever month we're in. And so we'll go product. So this is going to create a virtual table, a single column table with our 9 products, or less, fewer if they didn't have sales in whatever month we're in here. Okay, and so then we'll do total sales. Okay, and that's it. So this is a pattern you use all the time with SumX or MinX or whatever. And so this again creates a virtual table of the 9 or however many products were sold in that month. And then it references the total sales measure. Because it's a measure written like this, it triggers context transition. Okay, and so then what that will do is it'll take the row context, which is whatever current product we're iterating over on this table, and go and calculate the total sales. So we'll end up with a virtual table of the 9 products with their respective sales value, and then the max X will then just return whatever the maximum value is. So whichever product had the most sales, that's the number we'll get back. Okay, so let's finish that one out and add this to our visual. Okay, and if we compare that over here, let's move this to the side so we can expand this out. Okay. We will see that we go to the very top here, you'll see we get the value. So 684 was the maximum here, 616, 660. If we go down further, we got 1032 for March of 19. So we see we got our expected result. Okay. All right. So that's the max individual product sales, but that is a pattern that you will use again and again, where I create a virtual table, I iterate over it. For each one, I do a calculation, and then I return, it could be the sum X, could be the min X, the max X, average X, or whatever this virtual table that I've created. So really useful pattern, but requires context transition, and by referencing the total sales, it triggers that. If we didn't have this measure, right, then we would have to do, calculate sum of, sales, and we do have that total sales column, so we could use that in this case, and return that. And because we've wrapped it in a calculate, we get the same values back. Okay, and if we had neglected to put the calculate, so this is just like that calculated column example that we showed, you'd see that we would not get the correct answer, and actually what we would get is the sum of all 3 columns, because for every row it's there's no filter context, because it's all of the products being sold. So it's basically a virtual table for each product. Everything has the same sum of all the products, and therefore the maximum, of course, is that value, and that's what we see here, right? So that's not how we do that one, and we just reference our total sales measure, and we get our desired value. Okay. All right, so let's switch gears and talk about the next one, which is the rank of sales by product and category. So let's change that to a table, get rid of these columns, and then add in our product table, or our product values. Okay, and so now we want to do a rank of these values. So let's show our total sales again, because that'll be the thing that we're ranking over. Okay, and so let's add a new measure. And we'll call this one rank sales product. And so there's a very handy function called RankX, right? The X means it's one of these iterator functions. And so again, we're going to supply it a table. In this case, we will do the same as we did before, where we'll do, we could give it the values of the product column, but because we have the product column in our visual, the values function is only going to return the product on this row, right? So what we needed to use here is the all table, which will remove that filter and give us all of the values for products. So this is a one column table of all 9 products. And then we can again say the expression we want to evaluate. So again, this is written in measure form, so it triggers context transition. This would be enough because the default would put it in descending order, but we can go ahead. We don't need to use this value term. Maybe in a future video we'll show how to use that, but typically you don't need that one. And we'll go ahead and just do this descending so that the maximum sales will give us a rank of 1, and we will add this measure to it, and then we can sort by it, ascending, and so you'll see that the product C had the 21,000 sales, which was the highest value, and we got our sales ranked from 1 to 9. Okay. The request here was also by category, so we could write a second measure here, but I'll just go ahead and change this one, and I'll just delete that. And basically, if we add the category column to this, again, we're changing the table we start with, right? So our calculation may not work the way we thought it would. We'll add category, we'll put it first, and what you'll see here is if we sort this by category, you'll see that, you know, because we used all here on the product column, our filter on the category column wasn't removed, so you'll see that we get a rank sort of within each category, which may be exactly what we want. And you know, so these 2 and then these 4 and these 3 correspond to the number of products within each category. Again, that may be exactly what we want, but in case we wanted to have the 1 to 9 there, we have a couple options. So one is we could say, hey, I want to remove I want to look at the whole product table instead of just the one column, so I could actually rank X over the whole product table, and that would get me back to my 1 to 9 for totals, right? Because we've removed the filters from both of these and we're iterating over the entire product table. The other way to do that, and probably the way I'd recommend, would be to put 2 values in here. Remember, we can do this within an all, and we can do both. Remove give it this table, a 2-column table that has all of the combinations of product and category to iterate over. It then uses that row, so it would go and calculate total sales using the row context, which would include a value for category and a value for product, calculate the total sales, generate that virtual table, and then figure out which one had the highest rank. Okay, so this would get us the same results as the previous one, and would ignore both it would give you the rank across categories as well. Okay, so those are a couple variations on RankX that hopefully will help you do that kind of calculation. All right, so moving on to sales for top 3 products. So if we clean this up a bit and go back to just products and total sales, remember before we said, hey, we could use in the filter panel, we could do top-end filtering and pick 3 and then say we want to do it by total sales. But I'm going to show you now how to do it with the DAX expression. Okay, and so one way to do it would be to use the RankX function and basically say, calculate total sales, but filter it down to the products where the rank where the rank is less than or equal to 3. And that's a common way people do that. I like to do it a little bit different way. I like to use the top end function. Okay, and so let's make a new measure. And I said I want to get the top 3. And so we'll call this sales top 3 products. Okay, and so how we would approach this one is, again, we want to calculate the total sales, but we want to first change our filter before it does that calculation down to just the top 3 products. Okay, and so there's kind of 2 variations on this that I'll show you. One is we'll give you, this first way will give you the sum of sales for all 3 of those products combined. Okay, so let's do that. And so one thing we can do too is variables can also store tables, right? So far we've shown them where they store scalar values, max, mins, whatever. We can actually store variables in a table. And so I'm just going to call this top 3, and we're going to use a function called top n, which returns a table. So this variable will hold a table. We want to keep the top 3 values of this table we're going to provide. And again, we could use this values function. Well, actually, we're going to use all because what I said before of we have a filter on the product already. So the values of product A would just be product A, whereas all would give us all 3, all products, all 9 products, sorry. So we'll say all products, and how do you want to decide which are the top 3? So we would use total sales. Okay, and then we would say descending, so we want the top ones. Okay, and so now we have created a variable that is a 1-column table that keeps the top 3 best rows from the table of 9 product values decided by total sales. Okay, so now what we can do is we could return, and we'll say calculate total sales. Right, and so we're saying not just giving me the total sales in the current context, which are these values shown here, but we want to change that context, and so we're actually going to replace the list of products there in the current context. So on the first row, this would be product A, but we're going to go ahead and replace it with our top 3 table that we made above, right? And so this is going to replace that list of values. So it's going to replace the list of product A on the first row with the list of whatever the top 3 are. Okay, and so you'll see that it is giving the same number on each row. Okay, so maybe this is you wouldn't use this measure this way, but say you had a card visual over here, and you just wanted to show your consumers sales for the top 3, or you wanted to look so this would show again the same value. Here's the total sales for whatever the top 3 products were, regardless of what they were. Maybe you would make that a table and show that by year, month, right, where you would show what the sales for whatever the top 3 products were as a function of time, right? So that's where you would use that kind of function. This way it doesn't work here, but I'll show you the variation on it of where you may use this. And so if we do, if we can make a simple change to this, where we could say instead of replacing the list of products, we just want to add an additional filter on that same column. We could say keep filters, but still apply around that top 3. So what we're going to do here is it's going to keep the filter that's already on that row for product A, right? and then it's going to add an additional filter of whatever the top 3 product values are for that. Okay, and so only the top 3 products will successfully have results that make it through both filters, right? Whatever row I'm on, and so if A happens to be one of the top 3, we'll see a value here for A. If B is not, then B will not have a value. So let's go ahead and do that. So we did it with Keep Filters. And so now you'll see only these 3 products were in the top 3. And you see that the sum of those equals this 55,000 value that we see over there. And so this is a handy way to do this. So if we take away the total sales measure from this, the visuals automatically filter out blank values. And so you would be left with a table that only shows the sales for the top 3 products. Okay, so again, you could do top 3 with using a rank function as well. There's probably other ways to do it as well. This is how I like to do, show me a table with the list of the top 3 products using the top end function with Keep Filters, so that, again, only the top 3 products successfully make it through both filters. Okay, the filter from the visual on product, and then being in the list of the top 3 filters for that. Okay. Okay, let's move on and work on this measure here where we do the count of new products by month and year. So since we have year, month on our other table, we'll use this one. Get rid of the top 3 measure. And so this one, let's start our measure here. We're going to use context transition to get the count of new products. And by new products, we're going to define that to mean a product that's sold in whatever the current month is that's never been sold before, right? And so we'll call this measure new products. And we are going to use well, let's start one way just to make a point. We'll do the values of products from the product table to see how many products are sold in each month. And this is going to be an incorrect number at first, but I want to make a point with it. So if we just start with our measure of that says, okay, give me the values of product in whatever the current context is, and I add that to our table, you're going to see that we get the number 9 for all the values, right? And so this is saying, it looks like, hey, we're not seeing any filtering there because we know not every product is sold every month. Some of these came along later. But if we look back at our data model, we see that, okay, we're using a column from the date table and we're getting the count of products from the product column of the product table. Well, the date table doesn't filter that table, so it isn't going to reduce the number of products that are available in the current context, so therefore we get the number 9 for all of them. So to do this calculation, we're actually going to use the values in the sales table on product ID. So if we change that to that column instead, go to sales and we go to product ID, we can now get a count, and an extra parentheses in there, sorry. Now that'll give us a count of the number of products sold in each month. And you can see early on we were just selling 3 products, and then over time we added more products to the line, and at the end, at all months, all 9 products had sales. Okay, so this is a start, and so what we're going to do now is to say, hey, this is the count of all products that had sales, but we want the count of only the new products. All right, and so what we're going to do is filter this virtual table of products to the ones that never had sales before. Okay, so we're going to do what we need to do first is, because we're going to look back in time, we're going to be changing the filter context. So let's go ahead and make a variable that grabs our minimum date. So we'll do variable min date, and we'll say the minimum of the date table. And so that's going to get us the earliest date in the current context. And so now we're going to look for products that didn't have any sales before that date. Okay. So we'll call that previous sales. And we'll just make a virtual table here. And so we'll say we're going to filter this list of things, but we're going to use context transition to decide if we should count it or not. So we're going to make a virtual table of new products. So now what we can do is we're going to say we're going to look in the past and calculate if there were any sales. And so if we do a calculation that looks backwards and we don't get a result, that means this is the first month in which that product was sold. So if we do, calculate total sales, and like before, we remove the filters on the date table, and then we say that the date is less than the min date. And so now what we've done here is we've said, okay, create a virtual table of the products that did have sales. For each row, because it's wrapped in a calculate, it will trigger context transition, and we'll say go and calculate the total sales. But before you do it, remove all the filters from date, so allow it to look at all dates, but then refilter it back down to the dates less than the start of, in this case, the month that I'm looking in. Okay, and so that will do that, and then all we need to do from there is return. We've made this virtual table, so we can't return the previous sales variable as it is, because it's a table and we would get an error. So we need to wrap this table in account rows, and then that will tell us how many products is this the first month that they had sales. So if I hit enter on that, we should see a big change here. And basically, and again, this will work such that it only returns sales in the first month, because in the second month that any product has sales, the month before it would have had sales, and therefore it would have been excluded, right? So, these are the months in which new product sales occurred, and the way this is set up, because this is the first month in our model, and we only had 3 product sales in the first month, we get a value of 3, but then you can see in which month the other products came in and started having sales there. Okay, so that's the count of new products. Maybe not the best example to show, but at least hopefully you can see the syntax there and the logic. And again, this is a pattern that you will use, where you'll make a virtual table, and then often you'll use is blank, or you could wrap this in a not as well, where you could change it to change true to false basically, and say, I want the opposite, so I want the number of products where it wasn't their first sale, right? And of course, many more months come back there, and you can do it. So, is blank and not is blank in this approach is a pattern that I use frequently for these kinds of things. Okay, so I'll just delete that, since this measure is called is called new products. So I'll put it back the way it was. Okay, and so those are just a few examples of how to use context transition in a calculated table, or sorry, a calculated column. We used it in an iterator function, and that's a pattern that you'll use a lot. MaxX or SumX or AverageX. across a virtual table with a measure. RankX also uses context transition, top in, did in this approach as well, and then here's this last one. So hopefully that gives you some examples for context transition and will help you apply it to the measures that you write.